Do you want kind of thing? So.
Yeah, and in my experience, talking to customers, they don't most of the time come right out and say, I want this to be secure. But when you say, here's something we think you should do, it's important for security reasons, they're like, oh yeah, okay, let's do that. Very rarely do they fight, unless it's like, if you're like 160 hours or something, they might freak out. But
if you don't bring it up, they don't want to know.
That's right.
They don't want to know.
Yeah, yes.
It's like, I don't want to know something that's going to cost.
Well, and they assume we're the experts, right? I mean, so that's on our.
I think we're good.
You ready to go? Yeah. I think Matt's about ready, and that's a great point. I think just to add to that real quick. I mean, I think that's where E-gineering can fit into this. Like, there are companies out there that do, very kind of what I would think of as static pen testing, where they're just going to run these scripts against you and come back with reports. And they've got those things refined really well, and they're keeping up to date on what the best way to do that is. And we're just not specialized enough to do that. But there's a lot of vulnerabilities that are kind of in this in-between layer where, just like some automated test isn't going to pick it up. But if we come in custom, take a look at stuff, look at your code, look at maybe where some of the rough edges are in your API, we might be able to find some stuff there that's not going to show. It's perfectly compliant. It doesn't show up on pen testing, but it's a major vulnerability. So I think that's where E-gineering can kind of fit a niche there.
Yeah.
Ready?
Good. Yeah, and I guess another thing to that, like if you look at a lot of the big breaches over the last few years and some of the statistics, a lot of time it's not, a hacker that constructed some handcrafted buffer overflow to compromise. They just called customer support and got somebody to give them a password, and that's how they got into the system. So it's definitely not all technical, but I mean there definitely still are technical issues too. So I think there's already been a lot of introduction while we were doing that, but I'm Matt Rimmel. Matt Lorenz couldn't be here, but he helped out a lot. We definitely wouldn't have been as successful without him, so he definitely deserves a lot of the credit for all this too. So I guess if you don't know me, I came on board officially in July of this year. Before that, I was an intern here for like 5 years. Which is a record I'll probably hold for a while, I think. So I finished my bachelor's degree at IU in 2016, and then stayed for a year to do a master's program in security. Wrapped that up this year. So now I'm here. So I think today, I put some stuff together, but I also love, if there's questions, there's obviously security is like a huge and broad, scoped, and there's a lot of details, and there's no way to fit them all in. So if there are specific questions, I'd much rather talk about that than some of the things I planned. But I first think going to go over it's the project we did with Rolls-Royce, and some about that, and then kind of transition to just kind of some general security development and software development, and hopefully some practicals and stuff that apply to kind of our context. And then probably try to demo some of the tools that we used to kind of show how easy it is for us to run some of that against our own projects, to just make sure we're not leaving any low-hanging fruit, and also I guess to kind of demonstrate how scary easy it is to compromise stuff when it's out on the internet and things. So I guess first the project overview. The project owners and the people developing it was UI Labs, which is where the project Clay is on. We were actually hired by Rolls-Royce, who was kind of like a potential customer for that project, and they were kind of short on resources. They were planning like a formal audit, I believe, this month, but asked us to just kind of do like a preliminary review and just kind of give them a heads up before they spent, their time and money doing, their long formal processes, both in terms of like if the app was production ready, but also like from a security perspective, because they would be using the app, they'd be uploading a lot of their, intellectual property and things they wanted to make sure would be safe. So the project's been in development, I believe, for about 3 years. Some of the back-end code came out of MIT. So the app, I think, and maybe you can correct me if I'm wrong, but it's kind of like a reverse auction of sorts for manufacturers and people who need manufacturing services. So what Rolls-Royce is doing currently right now is they've got these models or things they need manufactured, but they want to protect it, so they fly in manufacturers and sit them around a table and show them like the designs and all the specs, and then they bid on it and figure out how much it's going to cost. But obviously that's really time consuming and expensive to do that every time you need manufactured. So what this app was targeting was to kind of be a platform where Rolls-Royce could upload, or really any customer could upload the information and the models and all whatever goes into that whole domain and field up to this website. The website's got some physics engines and simulation stuff in the background that will generate a lot of the information that the manufacturers need to give a quote without. We're going to try to demo that later. Really good tool. Turned up like 900 issues, 60 of which were related to security. So we were able to use that to kind of guide some more of our manual analysis. And then we also just spent some time jumping over the source code, looking for issues. And Matt found quite a few issues just doing that. And then generally, we just use the app thinking like an attacker. So we played around with the app for a while, tried to figure out how it was supposed to be used, and then we started thinking about how we could abuse it, and spent a lot of time just sitting next, almost like peer programming style, where we'd have two authenticated sessions open, and he would do something and then look at the response, and I'd forge a request, seeing if I could mess up whatever he just did, or just kind of playing with some of their security features that way. So discovered issues, committed credentials and their public GitHub, None of them were production credentials, but there was they had credentials for a test AWS server that they were using, as well as working credentials for a test Postgres database. So they weren't production, but I believe, if I remember correctly, like the Postgres test database had the schema and stuff in it. And I don't know if we verified that it was a copy of the production data, but in a lot of times that ends up what the test database has. So yeah, it's definitely an issue. We found quite a few endpoints that were vulnerable to SQL injection. And there were also a lot of endpoints that weren't vulnerable, but really only because of a fluke. They would pass 9 parameters into the function unsanitized, but only end up using 1 or 2 of them to construct the query. So in the future, if they ever added more, they would, create another SQL injection vulnerability. In the project, the documents is just their generic term for anything in like a project workspace. So there might be CAD designs, XML descriptions of sorts, and we were eventually able to run arbitrary CRUD operations on anyone's documents. And to make it worse, all of the project resources, so like users, workspaces, documents, things like that, were all enumerable. So like 1, 2, 3, 4. So it was actually possible. We didn't do it, but we could have just wrote a bash script to iterate over every ID and download all of the documents that have been uploaded to the project.
And then write another one that will go in and delete them all.
Yeah, we could have done that too.
Now you have all the things that no one else can do.
So actually, the only restriction that we ended up discovering was you just had to be authenticated. There was no check that you were authorized to access or modify those resources. You just had to have an account with the web app, which you can create a guest account, and that works just as well, like no verification or anything like that. There are quite a few places where there was no server-side validation. A couple places they had client-side validation without corresponding server-side. One kind of interesting instance, profile pictures. There was no sort of validation that it was even an image. I ended up uploading a PDF as my profile image. And I believe it actually tried to display it. So I mean, obviously it didn't. It showed an error, but I believe it got sent back and the responser was loaded by the browser. So I didn't try it, but I didn't find any code that would have prevented me from uploading like a multiple 100 gig binary file as my profile picture and having that served in HTTP responses. There was also another kind of cool, there was a timing attack on their file upload. I'm not sure why it was architected this way, but when you uploaded a file, it went to a temp server, and then the response had the address of the resource on the temp server, which just was tempserver.com/ whatever the file name was. And then somehow that got copied over into their production systems. I'm not sure if we ever figured out exactly how that was all architected, but one issue we found was if we both uploaded a file of the same name at the same time, whose ever came slightly after ended up in both people's workspaces because they both got the same name on the temp server, so the second one overrided the first one. And I don't know a lot about the manufacturing kind of domain, but I imagine like in software there's a lot of common file names like readme.md. And there wasn't any reason we couldn't have just spammed the test server uploading a readme.md every 100 milliseconds, and then every time somebody in the future would have uploaded that document to their workspace, they would have gotten ours, which could have easily been malicious or something like that. There was also some issues with document versioning. So there was kind of a rudimentary versioning system with documents where you could upload new versions and then select different versions to download. And there wasn't a lot of verification on that, so you could fake a put request where you modified what resource it pointed at as like a new version, so it would still show up as the same document name, but it would actually point to a totally different document. So when you went to download it, you got the document you pointed it at, which could, again, easily be malware or something like that. They also, some of the issues that kind of, I think, led to this was they had a really broken development process. Their build process was broken. Clay probably knows more. I don't think they could change or update dependencies, which was an issue since some of the static analysis tools we ran against the dependencies, like a lot of them were out of date and had known security issues. I think, I mean, just kind of the whole, it's just kind of a broken thing that they weren't catching a lot of these issues like they could have been had they kind of been using a more formal development process. They were also, even when we did bring up issues, they weren't really addressing tech debt and known issues, which I guess there's nothing we could really do about that other than try to make it clear that some of these issues were pretty severe. And then at the time, we couldn't run the project locally, and that included them, so they were sharing a dev server. I mean, I don't know if you really need to explain why, that's might cause problems, but yeah. And so I think a lot of this, doesn't probably apply to our context. I mean, I think we use a pretty good development process here, and there's a lot of really smart people that make sure we do it the right way. So we get a lot of these, we would avoid a lot of these security issues just kind of inherently. But I think it's still kind of good to know what happens. So I wanted to talk a little bit about just kind of security in general. Some of it basically came out of Chapter 1 of Computer Security Principles and Practice. So some of it's a little dry, but I mean, if there's questions, I'd much rather talk about that. But when we start talking about security and maybe possibly starting to integrate some of it into our development process, I think it's probably good to kind of have a good foundation of how security is formally expressed in these contexts. Instead of writing on, the requirements doc that, like we don't want to get hacked as a requirement, but break it actually down into a more formal and standardized way. Yeah. So some quick terminology. Most of them are probably self-explanatory. Adversary threat agent. It's just really anything or anybody that poses a threat. That might be a person, that might be bots. There's a lot of bots on the internet that just look for outdated versions and stuff like that. An attack is just an intentional attempt to exploit a vulnerability. Countermeasures, that could be technical countermeasures, like policies. When talking about a lot of attacks being social engineering and people, countermeasures can also include, your management policies and some things like that. Like you're not allowed to just tell people what the last 4 digits of your credit card are on associated with the account without actually verifying that they're the owner of the account. A risk. I lost my here. So the risk is an expectation of loss expressed as the probability that a particular threat will exploit it. So when you do some threat analysis and you come up with what the risks are, how you kind of rank them, they're typically like, if you have a threat that would be detrimental, but it's very, very unlikely, that would actually be exploitable, it ends up with, kind of getting a lower priority than something that might not have detrimental effects, but, anybody with a computer could easily exploit it. Security policies, those kind of go with countermeasures. Those are just the policies you set as a company. That might be development policies, testing policies, operational policies, things like that to try to mitigate some of these security issues. System resource, the really common ones, just your data that you've got is an asset, but it can also include like computation. So a lot of malware out there attacking IoT devices aren't actually trying to like steal data or anything like that. They're just using it to like mine Bitcoin. So they'll take over your smart light and it'll start mining Bitcoin for them. So in that case, the IoT devices have a computational asset that the attackers are after. It can also be, there's a common term kind of called pivoting. So like if you don't have access to the database, but you can compromise the web server, you can use that to pivot attacks onto the database because the web server has access to the database, things like that. So threat, we kind of already talked about, just really anything that might pose a risk. And vulnerability is pretty self-explanatory, just really anything that any sort of weakness or vulnerability that a asset might have or a application. So the Federal Information Processing Standards set out what's called a CIA triad. So obviously there's 5, which is not a triad. But the last 2 have kind of been canonically added in the community. Really, technically in the FIPS 199, it falls, authenticity and accountability fall under integrity. But to be more clear, they've kind of broken that out into some different ones because integrity ended up being a pretty broad term. But any attack, exploit, vulnerability can really end up being categorized under one of these. So like confidentiality, we want to prevent unauthorized users from accessing data, that they're not supposed to. Integrity usually ends up referring to like either data integrity or system integrity. So we want to protect the data. We don't want unauthorized users being able to modify any of the data that we're storing. We also don't want them to corrupt like the operating system, like installing rootkits or anything that would kind of corrupt the system itself. Availability can be both kind of like a functional problem, like if that you get DDoSed and it takes it down. I mean, now your users can't use it. It's a functional problem, but like in the case of I think Delta a few years ago, got their system completely wiped out, and it became a security issue because they couldn't verify, who were their authorized employees that could be in certain areas. They couldn't verify, who's actually supposed to be on these planes, where are these planes coming from, when was the last time they got checked, and it became, kind of like a security issue because they didn't have, that system, that asset, their application available. Authenticity is just verifying that, someone is who they say they are. If you have a failure in authenticity, that could easily lead to, a failure in confidentiality or integrity if they're able to get in there and do stuff. And then accountability is applicable in different ways in different contexts. A lot of times with, and the government and, some of those organizations, they want to be able to, take like recovery and legal actions, if somebody's compromised it. It's also just important for deterrence and like fault isolation. Like if something does happen, you want to be able to track down like either who did it or what did it. You don't want to just have a blind black box. We can't figure out what broke it. But some of the security challenges, a lot of times it's not as easy as it seems. A lot of them can be expressed as like one word, confidentiality, integrity, but actually implementing that correctly can have a lot of complex and subtle nuances, and that's, where a lot of technical attacks come from. It looks like it covered 90% of the cases, but those 10% of the cases that it missed, in your countermeasure, whatever it is. It's also a battle of the wits. So we, as like developers, are kind of more on the defensive side, are at a disadvantage because we have to get everything right, where an attacker only needs to find one vulnerability to compromise a system. So if you've got an API with 200 endpoints, if you miss just one from a security perspective, that could be enough to compromise the entire system. So it's not encouraging, but that's kind of what it is. And like the people who are hacking. Sometimes part of the problem is there's a lot of really good tools that are freely available. So even if somebody doesn't know what they're doing, if they can hit run, they're just as effective as somebody who's spent their entire life hacking or in that world. Another problem kind of in industry is there's little perceived benefit until a security failure occurs. And I actually took a class this past semester called Economics of Security. And there's a lot of papers kind of showing that from a purely economical perspective, it's not worth investing in security until after a failure occurs because you really don't have an idea of what it's going to cost you. Like companies don't want to spend $500,000 in security, to get compromised and kind of learn that all they were at risk of losing was a few $1,000s worth of, whatever. So a lot of people in, management positions and making these decisions, they don't see a lot of benefit. Security also requires a lot of constant monitoring and maintenance. And it's probably pretty self-explanatory. I mean, it's hard to, if you just deploy an app and leave it, it's hard to know, like, if you've been compromised. I mean, if you're not monitoring or somebody's not responsible for that, which also leads to a lot of other problems, especially, like they were talking about WP Engine being really good, but a lot of other hosting companies, they put it on the user to, like, maintain it. So if, like, vulnerabilities come out, it's up to the user to update their WordPress version or try to mitigate some of those issues. And, a lot of people, bloggers and stuff who aren't tech people, I mean, they're not doing that. But that's where, companies like WP Engine, they take care of all that for you, as you kind of heard when I brought down our website. So the other problem is it's often an afterthought. Even in situations where they do spend some time and money in security, it's after they've gone through design and development, and at that point, it's usually either too late, like it's really hard to implement security because you find, like maybe deep architectural issues with your design that you'd have to go and do a lot of refactoring, and it just can become like really expensive. And the other big problem is security a lot of times undermines convenience. There was a kind of an interesting attack, which I think is still valid, where you deploy kind of like a rogue access point, like wireless access point, and it's had its firmware modified. So what normally happens, like when you go home, your phone is sending out probes looking for its known access points. So like, is my home network here, and it's just sending out these probes. And what this modified router does is just say, yeah, here I am, and your phone connects to it. Right, because that's convenient for us. We want our phone to just connect. We don't have to put on a password every time when we get home and stuff like that. But that, especially in public places, can lead to just really getting transparently, compromised. Because even if you're not using your phone, a lot of times it's sending data in the background. So if there's a compromised app or something, I mean, you could be sending your data to an access point in this room and have no idea. But it also applies though, like when we're doing development, like. We want our stuff to be secure, but we don't want it to be to cause problems with convenience. Yeah.
As a side note, that's also the mechanism for the Stingray cellular system.
Right. Yeah.
It spoofs a cell tower.
Right.
The phone connects to that, and then it logs traffic and then sends it out to the actual cellular network.
Yeah. So from a user perspective, you have no idea that it's happening. Same with the Wi-Fi thing, because it just forwards all of your packets to an actual access point, but after it's had a chance to read it and see what you're doing. So one of the things that kind of apply to us and how we can start maybe moving towards some of these things is called a security development lifecycle, which is very parallel to your normal software development lifecycle. And the reason is, like, the application layer is the weakest point. 75% of money is spent on infrastructure at like companies and things like that, but most of the attacks target the application layer, where not as much money is being spent on security. And Microsoft, so actually these, I didn't, I guess, put credit, but these stats come from the Microsoft website. They've actually got a lot of really good security resources if you're interested in some of this stuff. I think I've got a couple URLs and links in here. But they did a little study and found that only about a third of developers are confident that they're writing secure code. And I would imagine that of that third, there's probably a percentage that think they are, but probably aren't. But I mean, it's hard, so you can't blame them. But so a step forward, not just for us, but kind of maybe the industry as a whole, is to start integrating this security development lifecycle, which also includes training developers in secure coding practices, and then incorporating threat modeling, secure coding techniques, secure code review, and security-focused testing into our normal development process, which, as we'll, I think, see in maybe the next slide, next slide or two that it's actually pretty easy. It fits in really nicely with most development processes without taking a lot of extra time or resources. So this image I grabbed off of, it's actually a Microsoft presentation, but it's hosted on the OWASP website, which has a lot of really good security information. But across the top is your normal traditional software development lifecycle. And then across the bottom is how the security part of that kind of plays in. So, during the envisioning phase, you also spend a little bit of time doing a risk assessment, and those usually get broken into just low, medium, or high risk applications. Like a WordPress site that we build that doesn't actually have like any sort of app component. It's just static pages and information. It's really probably a low risk application. I mean, there's not a lot in the application that poses any sort of of those CIA triad, problems. During the design, spending a little time doing a threat model and design review. So I've got a couple slides on threat modeling. It's a really big, I spent a whole semester on it at school. They had a whole class on threat modeling, and it could probably warrant at some point maybe another lunch and learn just on threat modeling, but there's a lot of really good resources. If you picked up the latest, I know Troy picked up a couple copies of that Humble Bundle, Security Bundle, and there's a book in there from a guy from Microsoft. It's called Threat Modeling. It's a really good book. That's what we used at college. Yeah. Yeah. Yeah, so if you've got time and are interested, it's a pretty good book. So then during development, when we're doing our normal code reviews, you do your internal security review. And that might be as simple as like, when you test an endpoint for functionality, you also throw one of these tools at it to see if, SQL map or Burp Suite return any issues. It can be pretty painless. And then when, your normal testing phase, you can also conduct a pre-production kind of like security assessment. So similar to kind of what we did with the Rolls-Royce project, but maybe at a much quicker, more automated. Once we can kind of build some of these knowledge bases and tools and processes, it could potentially be maybe somebody spends a day and throw some of these tools at it and just looks for low-hanging fruit, which is going to be probably the biggest issue that we have with our clients. I know with some pretty big clients. I don't know that any of them are, as big as like Apple's website or something where they might have to worry about getting DDoSed. I imagine most of our clients probably don't have a high risk of that. But any sort of low-hanging fruit that can get picked up by like a script or, a kid or something, we definitely want to make sure we're catching. And then, during release, post-production assessment, which is usually pretty simple. I think they're actually, I broke them down a little bit. Yeah, so risk assessment. It's really just application inventory and the risk categorization. So, a company that might have a lot of apps, you want to categorize, like what are our low risk applications, what are our medium risk and high risk applications, just to kind of keep an inventory and help determine, where resources need to be spent. Threat modeling design review, it's really intended to provide, a consistent methodology for objectively evaluating threats. And that kind of goes back to, we don't want to just write down like we don't want to get hacked. We want to be able to really express our security requirements in a formal way. You also spend some time reviewing application design to verify compliance with, the security standards and the best practices that we've, kind of decided on and verify that the application design is actually meeting those requirements. Internal review, like I was saying, just, during our normal development. I know I've gathered a few and kind of consolidate them, but Microsoft's got a lot of security checklists, and there's a lot of checklists for specific domains. Like I've got one specifically for Node. There's some Java-related ones, iOS-related ones, and those can be quick to run through. When you're doing a code review, like do we hit all these security checklists? And then if there are any sort of like development policies, things like that, above and beyond, that's a really good place to kind of verify those. Pre-production assessment. So like when we go into the normal testing phase, for low-risk applications, this is probably just kind of like a host-level scan. So since the code itself is probably not at a high risk or anything like that, but we want to make sure like when we deploy it onto a server, like we don't accidentally leave ports open that don't need to be open. If we plan to deploy it on a specific version of Linux or something, like verify that that was actually the version it was deployed on and we didn't actually deploy it on like an old version or something like that. Or like Apache, things like that that could have vulnerabilities. We want to just verify that we did what we expected to do. And then for high and medium risk applications, a lot of times, I mean, they'll do the host level scan, but they'll also do kind of like a white box code review like me and Matt did. And then in post-production, yeah, just kind of that host level scan after you deploy it to production, just verify that you actually did close the ports you expected to close. The versions are on the version you expected them to be, and there was no problems with those. Yeah, so these are some of those SDL resources I was talking about. MITRE is kind of the industry standard go-to for common weaknesses and vulnerabilities. You might have seen CVE dash some number, and those come from MITRE. So anytime there's a vulnerability or something like that that gets kind of recorded, it gets a CVE number. So you can go to like their website and search for Apache 7 and see if there's any known vulnerabilities for those versions. OWASP is another really good tool. They do, I believe it's every 3 years, they release like an OWASP top 10, which is geared, kind of a lot towards web development, but they list the top 10 vulnerabilities for kind of now, this time period. And a lot of times, most of them don't change. Like injection is still a problem, it's on there, but every now and then you'll get some new ones. Like XSS, or cross-site scripting, was on there for a while. I think on the newest version, it actually came off because a lot of frameworks and things like that are handling that by default now, where they didn't used to. It's also probably worth looking at some static code analysis tools. So we use SNCC and find bugs. SNCC checked for dependencies. So I think it can handle Ruby, Node, Java, I think Python too. It'll automatically look for all the dependencies and cross-reference them against a vulnerability database and give you an alert if like, hey, this package you're using has known vulnerabilities or you're not on the latest version, things like that. And then find bugs was great just for a general static analysis tool. And usually there's some sort of tool for probably everything. I think C#'s got some. I think there's some iOS ones too. And like I said, there's some security checklists. I've been compiling some. I think right now they're in GitHub, but we've talked about trying to move some stuff to Confluence and start building kind of up a knowledge base that way of kind of like what E-gineering, like what we've decided we need to include and make sure that we're doing in our applications. That book is another really good one. Oh, and these elevation of privilege cards, I think I got some. So they're kind of in the same spirit. It was developed by the same guy who wrote the book. It's kind of the same spirit as the planning poker, where you kind of play it as a team. But I've also got, let me pull up the PDF. You probably can't see these, but each card, so it's like your 2 through ace, and there's different vulnerabilities, all categorized in like information disclosure or denial of service. And the team, the idea is kind of the team sits around and they look at their design and things like that, and they kind of play through the cards and try to find places where hey, like this might lead to a denial of service if this happens, right? And then you record those. And the point's just really to get everybody around and thinking in a security context about the design and trying to find potential issues before we spend a lot of time developing and have to go back and fix them. So these are just kind of what it looks like. I got these printed off from like a company in Europe. They're relatively cheap. I might talk to Don or somebody about picking up a few to have around if people are interested. But that can be another cool kind of practical tool to use. So, and then some of the secure design principles. A lot of these you've probably kind of picked up as common sense, over time. But economy of mechanism really just says like keep it simple. If it's the same kind of idea with bugs, right? If you create a class or something that's incredibly complex, you're a lot more likely to have bugs that you know about or introduce bugs. And the same applies for security. If you implement a bunch of mechanisms or something that are incredibly complex, it's more likely that you've probably not done it quite right, and there could be some security issues. Fail-safe defaults. As a common example, it's permission rather than exclusion. Kind of the good example is like, if you're checking authorization for a resource, you want to kind of assume they don't have access to the resource until, there's some sort of permission that proves that they can, instead of kind of the default being, like they can access this resource unless these conditions, are hit, because you're a lot more likely then to mess up one of those conditions and lead to a security issue. And it's also a lot harder to find, because when you go through and do a functional test, you log in as your user, you access the resource, so cool, it gave it to me, and you don't realize that really anybody could have accessed it to you because your code's wrong. But if you do it the other way, you go and do a functional test, and like, I'm an authorized user, but it's not letting me access this resource, then you can learn that you didn't actually implement those authorization checks right. Complete mediation is really just saying, a lot of it comes from like kernel development, some other more like low-level tools, but caching can cause problems. If permissions change, how those propagate through a system, and it's really just saying like, when feasible, because obviously you don't want to do a check every time they want to do something, because that can be very cumbersome, but you want to make sure that you're adequately checking authorization over and over again in case some sort of like system state has changed. Open design probably doesn't really apply to us. That's more of like cryptography and those things. Like, you don't want to depend on obscurity as security. You don't want to depend on somebody not having access to the source code as being like a plus for security, because in reality that doesn't matter. Least privilege, like it's kind of the classic Snowden example, right? Like he had administrative access he needed for like a specific part of all the NSA systems or whatever, but when they gave him admin privileges, it just gave him admin to everything. So he just wrote a crawler to access stuff that he really had no need to access. So we want to make sure, like when we're designing systems, that the other one, like never run Apache as root, right? Apache doesn't need to be a root process to run. So don't do it. It needs to have the least, kind of the least amount of privileges needed to run. Psychological acceptability is another one that applies. Like we want to keep it usable. That's kind of that. Security doesn't, or convenience trumps security a lot of cases. A lot of these are, again, like just kind of self-explanatory, keeping things isolated and encapsulated. Like your database doesn't need to be accessible on the internet, right? It should be behind, firewall and network. But in a lot of cases, like there's a search engine called, spacing on the name, but it lets you search for things like databases on the internet, and a lot of times they're just open to the internet and they have default credentials and things like that. So keeping things modular, layering, defense in depth is a good one. You don't want to depend on kind of like a single point of failure. Those are never good. You want to make sure you've got layers, like maybe firewalls, authentication checks on the client side, authentication checks on the server side, authentication checks before you access database resources. And then least astonishment really just says that it should be transparent as possible. You don't want to implement a bunch of security mechanisms that kind of throw the user or like confuse them of like why we're doing this, or it's not what they're kind of normally used to. Threat modeling, I might kind of skip over some of that. It's if you're interested, that book is really good, but it's really just kind of the same stuff we do when we're looking at functionality requirements, but kind of applying it to security. A couple of the example diagrams, like the attacker might be able to read messages. Everything in orange is what might go wrong that would allow them to do that, and then the stuff in green is what we can do to mitigate those. And a lot of times that's as easy as it is. It's just kind of looking through the diagrams we've already got, looking for places where there could be security issues or vulnerabilities, and then figuring out and documenting kind of how we can mitigate those during the design phase. We can do a little bit of demo of some of the tools, because what could go wrong trying to hack stuff in front of people, right? So originally, I think Andy, I don't know if he's here, but he gave permission to look at Dashboard, the staging version, to see if there was any issues, but we actually didn't find, I didn't spend a whole lot of time, but I guess hats off to Andy for writing a good, secure dashboarding application all by himself. But what I did do was download a something called BWAP, which is just it's running as a VM on my machine, and it's designed to be just intentionally vulnerable. It's got all kinds of issues. So we're just going to show some of the tools that we used when we were doing our audit, and a lot of them are simple enough to either kind of automate into a development process or really quickly just run ourselves. Let me find my notes somewhere. Way too many notes. Went a little overboard. Okay. So first, I guess I might just show some of those websites I was talking about. MITRE is a corporation. They handle, like I said, a lot of the common weakness. They've got IDs for a lot of the common weaknesses that happen, and they've also got they keep a database of the common vulnerabilities and exposure. So if you ever need, if you're looking at your frameworks and things like that, this is a really good site to come through. Somewhere you can get to a search. I don't remember exactly where it is, but you can search for your frameworks and things like that to make sure that there's no known issues. And then also the OWASP website that has the top 10. Well, it's somewhere. Here we go. So these are the top 10 for 2017 down here. And then there's also links in here to get more details and description on those. So probably not a bad thing to try to familiarize yourself with at some point of just kind of what the common attacks out there are, because some of them might be things that you didn't really think about. Okay, so let's go back over here. So one of the tools we ran was called SNCC, and that checks for vulnerabilities and like your dependencies and stuff like that. And that's and they've actually got you can register. I think you can do credentials too. So if it's in like Bitbucket protected, you can actually register with them while they'll run every time you add a new dependency, or just over time they'll kind of monitor it for you, and you'll get notifications if it finds any issues either now or in the future. So SNCC is as simple as just running SNCC test in kind of the root directory, and it'll query the vulnerability database. And so this is that DMC REST. Found 24 vulnerabilities in different packages. So this is running against Java, but it also works with like Node, Ruby, which I don't know that we do a lot of here, and then Python. And then find bugs. I don't know. I know some people have said that they've used it, but it's pretty simple to run. And this is what we actually use to find a lot of our SQL injection vulnerabilities, because it got us kind of started in the right direction. So for find bugs, you just go start a new project, and then in our case, it's deployed as a WAR file, so you just give it the WAR file. And you can also give it a path to the source code, and when it shows you the report, it'll correspond the issues and actually show you the source code, the problematic source code right in the UI. If I can.
also has plugins for all the major IDs and integrates into Maven and Gradle and all that.
So it just needs, I think, the Java folder selected. And it'll run. It doesn't take that. It actually runs kind of surprisingly fast from my perspective for as many issues as it found. But it seems a lot longer when you're doing it in front of people. So 977 issues. Some of them, aren't security related. They're just, bad practice or, like internationalization issues. But these were kind of what we looked at down here. These potential SQL problems. The kind of color codes them. But so this was one case where they were using a prepared statement, but they weren't using it properly. They were.
Anyone tell us what's wrong with this? Maybe we should open it up to the code.
So it turned, like 50 something different. So they were using a prepared statement, but they were passing a string into the statement, which was not sanitized or static, so it kind of defeated the whole purpose of using a prepared statement.
Prepared statement will sanitize your inputs to make sure that they don't have SQL injection type stuff. What they did was here's where the input is, and they just like put it all into a single string and then pass it in there. So it's put input into here so it can be sanitized. They just like didn't do it at all.
Yeah. So Matt was actually able to exploit these manually using his proxy that he was using. And then I was able to go back a couple days later and use one of the tools to kind of automate it, and it found the same issues. So that let us get into the database. We could see all the tables, all the records. In theory, we could have also, in a lot of cases, it kind of depends on how your database is configured with permissions and stuff, but you can actually get a shell on the server through a SQL injection, which then, depending on what privilege level the database user is running at, you can wreak even more havoc. So that's find bugs. I just wanted to quickly show how easy it is to kind of run through that. So let's see what next. So one of the other tools we used was Nmap, which you might have heard of. It's a port scanning tool, but it can also do some other things. Like it's got a scripting language, so you can script either exploits right into Nmap, or just if Nmap finds open ports, there's scripts that'll try to analyze the service running on it and give you more information about like what version's running on this port. And things like that. So if I point it at that VM I've got running, it takes 71 seconds because I timed it. But you can already see there's a lot of ports open on this VM. We'll see when it kind of breaks down. A lot of them shouldn't be open, or at least should be black. So they've got MySQL running. They've got FTP service running that accepts anonymous logins. And then I don't even know what some of these other services are, but that's a lot. Typically, at least something that's deployed, you want to have, kind of the least amount open. If you need to run a web server and things like that, but if you don't need SSH open, if you don't need FTP open, those introduce their own potential vulnerabilities if either new vulnerabilities come out for those services or, they're not up to date for some reason. And things like that. So Nmap can be as simple as just Nmap and then either the URL or address. The -A just tells it to basically run everything, scripts. It'll do OS fingerprinting, so it'll tell you the exact, in a lot of cases, the exact version of Microsoft or Linux or everything that's running, which you can then use to look up in the CVE database. So I looked through this earlier. There's other things like it was able to find, access both the public and actually download the private key too, which is in here somewhere right here. So here's the private key. Oops. So so this is that intentionally vulnerable. This is nothing. Yeah, sorry. I don't know what that window is. There we go. Somewhere in here. it reports, so like the HTTP methods, it shows trace being supported, which best practice says should probably be off by default because it's used for debugging and could potentially lead to some information disclosure and things like that. Yeah, so here's the anonymous FTP login, and it actually showed the files in the root directory when you get on the FTP. Yeah, there's a lot of output. Usually it's not this much if you just run the basic scan, but it also somewhere in here shows the exact like Linux version and operating system and stuff like that that's running. So that can be a good tool to just, either pre-deployment or post-deployment, just hit it real quick with Nmap and make sure you don't have any ports or any things you don't expect to be open that are running. And no, I don't want to display. Okay, so these next couple tools are a little bit more interesting. Nikto is a tool that just looks for kind of default files and versions and things like that. It's really simple to run too. Sometimes it'll take a little bit longer to run. On this one, it runs pretty fast, but it ends up showing like, so like SSL is out of date, Apache's out of date, PHP's out of date. The X-frame options header to prevent clickjacking isn't set. The server leaks inodes via e-tags. Some uncommon headers. So these X powered by headers a lot of times have specific framework information in them that shouldn't be sent back because it just makes it that much easier for an attacker to target your application if it knows you're using this version of this framework. So that's another pretty good quick tool that we used. So then Burp Suite was what I spent most of my time in. It's a security, so it's a web proxy that's kind of oriented towards security. But what you do is you point your browser at it, and then you would just run through the application like you normally would, and it'll do by default, well, with the pro version. So there's a free and a pro version. The free version works great as just a general purpose proxy, but doesn't have all of the more specific security tools enabled. So here's this web application. And by default, it'll intercept the requests. So I want to turn it off. I'm trying to remember. Yeah, so over here, it'll detect anything going through. We're just interested in this, so you can actually tell it to hide everything that's not in the scope you set if you just want to be looking at this application. But while you're browsing, maybe doing your normal testing, everything you would normally do, it will kind of do some passive scanning in the background. So it caught that there was the submission of the password was in clear text, not over SSL and anything like that. The other really nice thing you can do, and actually with the free version too, is tell it to spider it. So it'll just start crawling, and it'll actually prompt you if there's it comes across forms that it needs data for, but I'm just going to ignore those for now. So I use this a lot when we were testing the application, and with some of the more pro tools, you can actually have it also actively scan. So it'll start looking for SQL injection. There's a whole list. I don't even remember, but those are usually the ones we're concerned about. So like XPath injection, it's finding all kinds of them. Flash cross-domain policy, it flagged it as severe. I don't know if I know off the top of my head exactly what that is, but so I don't think it supports Postgres, so I ended up having to use the SQL map, which I can show next, but it supports MySQL, Microsoft SQL, Mongo, there's a few of them, and I think also SQLite. So that'll run for a while, but if I can get to here, so this is actually a pretty cool app if you're interested in kind of playing around. It's, like I said, intentionally vulnerable, but it'll actually you can set your security level. So if you just want to learn some of the introductory stuff, or if you want to get to more of the advanced stuff, you can actually change how vulnerable the application is right in the interface to make it harder on yourself. Okay, so this is, I'm just going to search for something. So that made a post request, which Burp Suite caught somewhere. If I can figure out where it stored it. Yeah, so right here. So this was that request. And from Burp Suite, you can actually save it in kind of a standard format that a lot of different tools will recognize it. It basically just encodes the request and response with some of the metadata, so that tools like SQL map can parse it. Oops. So then with SQL map, if you just give it that log file, it will start scanning. So it'll prompt like, do I want to? Okay, yeah. So it actually found that search endpoint was actually vulnerable to SQL injection. So SQL map found it right here, and it asks you if you want to exploit it, which you can automate a lot of it, but the interesting thing about SQL map, even though it's a command line tool, it stores session data in your user directory. So if you do a big long 6-hour scan on thousands of endpoints and it finds a bunch of issues, it caches those. So next time you go back to run scans, it doesn't go through that 6-hour scanning process again. It'll already see these were the endpoints that I found. I don't need to rescan it, things like that. So to exploit it, all you really need to do is pass that. You can either pass the URL directly, or like I said, it caches it, so you can just pass that log file back to it that's got the URL in it, and then just do -- dump. And it'll start dumping the databases, which is, pretty scary easy. If you ask me. It also found, so it detected that it found some hashes and asked me if I want to store them, which are right here. And it'll actually save them in a separate file so that you can pass it off to Jack the Ripper or another tool that then break those hashes into the clear text passwords. So yeah, so that's really how easy it was once we spent some time identifying where the different vulnerabilities were. That's kind of how easy it is to then take advantage of those, which is also part of the problem with these tools being freely available. Is it doesn't take a lot of technical knowledge to be able to compromise an application. You can also kind of depending on how some of the context of the SQL injection, you can write new data to the database. Depending on how the user and things like set up, you could potentially pop a shell on the server, install rootkits if you've got the permission, things like that, or take advantage of a vulnerability in the OS to then escalate your privilege to root, if it doesn't already have it, and you can start pivoting kind of that way through some of these attacks. So I guess that was kind of it for the tools we used. There's a few others, the GitHub scanning. Those are kind of equally, I think GitRob was one of them. You just GitRob in the URL of the GitHub, and it'll scan the GitHub and all the Git history for credentials, things like that get committed. And there's a number of other tools. If you just look around, you can find plenty of them, but a lot of them really aren't that hard and would be pretty easy to, in my opinion, kind of integrate into our normal kind of code review process. Point SQL map at the endpoint that you just made sure was functional, and make sure that SQL map doesn't find any issues, because it's pretty thorough. It's been around for a while, and it's a pretty highly regarded tool. It'll check hundreds of different subtle, SQL injection techniques and timing attacks and all kinds of stuff. So I guess, are there any questions? That's kind of a lot. Some of it's dry, but
we're at time. Can I say?
Yeah. Yeah, go for it.
We could stick around for questions, but No. Yes. Okay. Yeah. Right. Can you guys hear me?
Yeah.
Okay. It's like messing with my mind. All right, so I just want to make a couple quick points here, and then you guys can stick around. It's 1 o'clock, but you guys stick around and ask questions. How long are you going to be here for?
I can be here for a little bit. Yeah.
You can be here forever, so just like take all afternoon. So a couple homework assignments for you guys. So first of all, obviously Matt knows a lot about security.
Matt Lorenz too. I mean, Matt Lorenz deserves a lot of credit too.
Yeah,
he
and Matt
he
Lorenz.
was pretty. Yeah, he did a lot of manual. I'm pretty impressed, honestly, that he found. I was trying to use a lot of automated tools and stuff, and he was just kind of banging on it himself and found a lot of issues. So.
Yep. So this is obviously something that we want to be able to keep Matt busy working on all the time, and there's a couple different ways we can do that. We kind of alluded to it earlier, but one is for external clients, can we come in and do kind of this sort of mid-range, sweet spot for E-gineering where we can do some security analysis like we did for the Rolls-Royce project. Another is for internal projects. Can we do some of the integrated, let's include some security steps through the processes. So your homework is be thinking about that. Think about other ways that we could employ kind of our growing security specialization. I think it's not really a practice right now, but we kind of like it if we're going to keep growing, I think that's something we want to think about. So be thinking about that. The other thing is, if you are interested, if you think this kind of stuff sounds fun and you want to kind of sign up for the possibility to do this kind of stuff, let me know about that too. So.
Yeah, I guess one more quick thought. I actually read this morning. Another thing is it's a pretty big deal. I mean, security, especially these days. And actually, yesterday was Equifax. Like a huge dump. I mean, it's like every day. But it doesn't necessarily have to be the code that we write personally. One issue I read about this morning that I thought was interesting is there's an XML attack called Billion Laughs attack. And I guess there's this thing in XML called custom entity, kind of like you do your ampersand LT for a less than symbol. So when the XML processor goes through, it replaces that with a less than, but you can define your own custom entities with ampersand whatever. So there's this attack where you do like ampersand LOL equals LOL, and then ampersand 2 or ampersand LOL2 equals 10 of the first level LOLs. You do that like 10 times. So when it goes through and your XML processor starts expanding those, like you end up with it injecting like billions of LOLs into the XML, and you can easily crash a server because it runs out of memory. I believe actually Java sets a limit on expansion to like 60,000 or something like that. But if you're using like an old processor, XML processor, things like that, it can be vulnerable. So like if you're not, maybe you're sanitizing XML, but if you're not looking for those things, like you could still end up with issues in the libraries you're using. And there's all kinds of examples like that where it might not be the code we wrote directly, but the tools and libraries we're using could have issues of its own. So yeah, that was that. But so are there any questions? It's kind of a lot, but all right. Well, thank you. Yeah.